60,000 years ago, something stalked early humans through the frozen forests of Ice Age Europe. Massive, powerful, with eyes adapted for hunting in darkness. A creature that seemed built for one purpose: killing our ancestors. Author Danny Vendramini refers to this as the Neanderthal Predation Theory, and for a decade, it has provided a chilling explanation for human evolution and our deepest fears. But what happens when we test this nightmare against the archaeological record? According to Danny Vendramini's vision of Neanderthals, these weren't the stocky, human-like cousins we imagine from museum displays. Instead, they were far more terrifying. Apex predators covered in thick, dark fur, with enormous eyes that gleamed in the darkness of Ice Age nights. The Neanderthal Predation Theory positions these creatures as hypercarnivorous hunters, whose primary prey was humans, not mammals. For tens of thousands of years, Vendramini argues, they terrorized early Homo sapiens populations across what he calls the Levantine freezer, the frigid Middle East of the last ice age. Every aspect of their anatomy, every behavioral trait, closely resembles an evolution for hunting humans. This wasn't casual predation. According to the theory, Neanderthals were strictly nocturnal, using their massive eyes to track human settlements in complete darkness. Their intelligence, while considerable, was focused entirely on the hunt. They lacked human empathy, human culture, and human symbolism. They were, in essence, the perfect killing machine designed by evolution to prey upon our species. The theory goes further, suggesting this predatory relationship shaped human evolution itself. Our fear of the dark, our instinctive terror of certain facial features, these are supposedly genetic memories of nights spent hiding from Neanderthal hunters. Every human alive today, Vendramini claims, carries the psychological scars of this ancient reign of terror. The implications are staggering. If true, it would mean that for much of human prehistory, we weren't the dominant species. We were prey animals, shaped by predation pressure from creatures that looked almost human but possessed none of our compassion. Our entire evolutionary trajectory, our cooperation, our technology, even our capacity for abstract thought, would be the desperate adaptations of a hunted species. This narrative has a seductive power. It explains human psychology through evolutionary trauma. It gives our ancestors a clear, terrifying enemy. It transforms the story of human origins from one of gradual adaptation into an epic survival tale. But seductive narratives, especially in science, demand the most rigorous scrutiny. The anatomical evidence really does seem to back up Vendramini's vision. When you look at Neanderthal skulls, you can see they were built along very different lines than modern humans, and those differences look almost perfectly designed for predation. The most striking feature? Their eyes. Neanderthal eye sockets are huge, far larger than those of any modern human group. If you imagine the soft tissue reconstructed, those eyes would have been massive, almost bulging, and capable of pulling in huge amounts of light. Their skulls tell a story of incredible physical power. The brow ridges are double-arched and pronounced, creating a face that looks nothing like ours. The muscle attachment points on their skulls suggest jaw muscles powerful enough to crush bone. Their entire cranial architecture speaks of violence. Below the neck, Neanderthals were built like biological tanks. They were shorter than modern humans but incredibly robust, with barrel-shaped chests and limbs thick with muscle. Their bones show adaptations for tremendous strength, the kind of power needed to bring down large, struggling prey. The isotopic analysis of Neanderthal bones reveals a diet almost exclusively composed of meat. These isotope ratios place them at the very top of the food chain, consuming more animal protein than any known human population. They were hypercarnivores, their entire physiology adapted for processing meat. Archaeological sites across Europe tell the same story. Neanderthal camps are littered with the bones of massive animals, cave bears, woolly rhinos, and mammoths. But mixed among these remains, archaeologists have found something more disturbing: evidence of cannibalism. Cut marks on Neanderthal bones match those found on butchered animals. At sites like El Cedron in Spain and Moulagersi in France, the pattern is unmistakable. The tools they made also suggest predatory behavior. The Mysterian industry produced sophisticated stone points, many of them designed for hafting onto wooden shafts. These weren't multi-purpose tools. They were weapons, crafted with the kind of precision that comes from a life spent hunting. Even their apparent intelligence seems predatory. Neanderthals had large brains, sometimes larger than our own. But according to the theory, this intelligence was specialized, the cunning of a predator rather than the abstract reasoning of a true human. They were smart enough to track prey, to coordinate ambushes, to anticipate human behavior, but they lacked the cognitive flexibility that allowed Homo sapiens to develop art, language, and complex social structures. So the overall picture is chilling. Beings perfectly adapted to play the role of humanity's nightmare. From their giant light-gathering eyes, to their tank-like builds, to their meat-heavy diet, every feature seems to fit. And yet, as archaeology often reminds us, appearances can be deceiving. The first cracks in the predation theory appear when we look at the Neanderthal diet through bone chemistry. Isotopic analysis, the study of chemical food signatures, shows a more complex picture than simple hypercarnivory. Neanderthal bones do show meat-heavy isotope ratios, but examined closely, these signatures matched animals that fed on large herbivores: mammoths, rhinos, reindeer, bison. Human consumption would leave a different, more omnivorous pattern. The bones point to mammoth hunters, not human hunters. This distinction matters enormously. Hunting a woolly mammoth requires fundamentally different strategies than hunting humans. Mammoths are massive, dangerous animals with thick hides and deadly tusks. Bringing one down would require sophisticated tools, coordinated group tactics, and incredible bravery. It's the kind of hunting that demands the highest levels of social cooperation and technological innovation. Cut marks on animal bones confirm this. They appear in precise patterns, showing skilled butchery aimed at extracting maximum nutrition. Their placement reflects deep anatomical knowledge, honed over generations of hunting. But the isotope evidence revealed something else: significant variation between different Neanderthal populations. Some groups showed the heavy meat signatures of dedicated big game hunters. Others showed more mixed patterns, suggesting diets that included substantial plant foods. This variation contradicts the idea of a single, specialized predatory behavior. Instead, it suggests adaptable populations responding to different environmental pressures. The cannibalism evidence, while real, takes on a different meaning in this context. The cut marks on Neanderthal bones are found at specific sites during apparent periods of stress. Rather than evidence of predatory behavior, they likely represent survival cannibalism, desperate measures during times of extreme scarcity. Modern hunter-gatherer populations sometimes resort to similar practices during famines. More importantly, the frequency of cannibalism evidence is actually quite low. Out of hundreds of Neanderthal sites across Europe, only a handful show clear signs of cannibalism. If Neanderthals were specialized human predators, we would expect to find such evidence at virtually every site. Instead, we find the occasional desperate act of survival. The bone chemistry was pointing toward a different story entirely. These weren't specialized human hunters, but adaptable omnivores who focused their hunting efforts on the most dangerous game available. The isotope signatures revealed creatures capable of bringing down Ice Age giants through skill, cooperation, and courage. The revelation of Neanderthal plant use came from their teeth. Hardened plaque, dental calculus, preserves microscopic traces of everything eaten. When analyzed, it revealed a hidden world of botanical knowledge. Starch grains embedded in Neanderthal dental calculus revealed consumption of cooked barley and legumes. These, which were thought to be accidental ingestions, were instead the grains that showed clear signs of processing and cooking. Neanderthals were deliberately gathering, preparing, and consuming plant foods, behavior that requires detailed environmental knowledge and planning. Even more striking were chemical traces of medicinal plants. Compounds from chamomile and yarrow appeared, herbs with no nutritional value but known therapeutic properties. Chamomile eases inflammation and digestion. Yarrow aids wound healing and pain. Their presence suggests Neanderthals practiced plant medicine. This evidence challenges the predation theory. Specialized predators don't process grains or seek medicinal herbs. The calculus revealed a species that understood hunting, gathering, processing, and healing. The plant evidence also revealed seasonal strategies. Different Neanderthal populations showed different patterns of plant use, suggesting adaptation to local environments and seasonal availability. Some groups relied heavily on nuts and tubers during the autumn months. Others showed evidence of spring green consumption. This wasn't opportunistic foraging, but systematic exploitation of botanical resources. Cooking evidence proved equally important. Many plant remains showed deliberate heating, making foods more digestible and nutritious, or detoxifying bitter plants. The medicinal plant use revealed something even more profound: abstract reasoning about cause and effect. Understanding that certain plants can treat specific ailments requires the ability to observe, remember, and apply complex relationships between consumption and health outcomes. This kind of thinking goes far beyond the specialized intelligence of a predator. The botanical evidence painted a picture of creatures deeply embedded in their environments, possessing sophisticated knowledge systems passed down through generations. They weren't alien predators stalking human prey, but fellow human species adapting to Ice Age Europe through detailed environmental knowledge and technological innovation. 176,000 years ago, deep inside Bruniquel Cave in southern France, Neanderthals accomplished something that should have been impossible according to the predation theory. They broke off hundreds of stalagmites from the cave floor and arranged them into 2 large rings and several smaller structures. This wasn't accidental. It wasn't survival behavior. It was architecture. The Bruniquel structures required careful planning. The stalagmites had to be selected for appropriate size and shape, then broken off with precision to avoid damaging the cave floor. The builders had to transport these heavy limestone formations across uneven cave terrain in complete darkness. The final arrangement shows clear geometric principles, circles and lines that required spatial reasoning and collaborative effort. The construction demanded fire technology. The cave extends hundreds of meters underground, far beyond any natural light source. Every aspect of the construction would have required artificial illumination. The builders had to maintain fires throughout the construction process, managing fuel resources and preventing smoke accumulation in the confined space. Most remarkably, the structures serve no obvious practical purpose. They aren't sleeping areas, cooking hearths, or tool manufacturing sites. They appear to be purely symbolic constructions, monuments built for abstract purposes we can only guess at. This represents a level of cognitive sophistication that the predation theory explicitly denies to Neanderthals. The dating of the structures proved crucial. At 176,000 years old, they predate any modern human presence in Europe by more than 40,000 years. This wasn't learned behavior copied from Homo sapiens, but indigenous Neanderthal innovation. The structures demonstrated that complex symbolic thought evolved independently in the Neanderthal lineage. The collaborative nature of the construction revealed sophisticated social organization. Building the Bruniquel rings would have required multiple individuals working together over extended periods. Someone had to coordinate the effort, maintain the fires, transport materials, and execute the geometric design. This level of cooperation requires communication systems, shared goals, and social hierarchies. The cave location itself suggests ritualistic behavior. Bruniquel Cave is not a convenient habitation site. It's deep underground, difficult to access, and offers no practical advantages for daily life. The builders made a deliberate choice to create their monument in this hidden, sacred space. Archaeological analysis of the construction site revealed evidence of repeated visits. The structures weren't built in a single episode, but modified and maintained over time. This suggests the site held ongoing significance for Neanderthal communities, a place they returned to for purposes we can only imagine. The Bruniquel discovery transformed our understanding of Neanderthal cognition. These weren't creatures limited to predatory intelligence, but beings capable of abstract thought, collaborative planning, and symbolic expression. They could conceive of purposes beyond immediate survival and work together to achieve complex goals. At Shanidar Cave in Iraq, archaeologists discovered something that definitively contradicts the image of Neanderthals as brutal predators: evidence of compassion. Among the human remains was an individual who became known as the Old Man of Shanidar, a Neanderthal who lived to approximately 40 years old, despite severe disabilities that should have killed him decades earlier. The skeleton revealed a life of extraordinary hardship. The individual had suffered a massive head trauma early in life that left him partially blind and likely cognitively impaired. His left arm was withered, possibly from birth or early injury. Severe arthritis had twisted his spine and limited his mobility. By any measure of Ice Age survival, he should have died young. Instead, he lived for decades with these disabilities. The only way this survival was possible was through sustained care from his social group. Someone had to provide him with food, shelter, and protection. Someone had to ensure he wasn't abandoned during seasonal migrations or times of scarcity. This wasn't temporary assistance during illness, but lifelong support for a severely disabled group member. The care extended beyond mere survival. Analysis of the individual's teeth revealed he had consumed the same types of processed foods as other group members. He wasn't receiving scraps or leftovers, but sharing in communal meals. The community was investing significant resources in keeping him alive and comfortable. Similar evidence appears at other Neanderthal sites across Europe. Individuals with healed fractures, evidence of long-term illness recovery, and signs of disability care appear throughout the archaeological record. At La Chapelle-aux-Saints in France, researchers found an elderly Neanderthal who had lost most of his teeth years before death, but showed no signs of malnutrition. Someone was preparing soft foods to keep him nourished. The pattern extends to traumatic injuries. Neanderthal skeletons show evidence of violence, broken bones, weapon wounds, and signs of interpersonal conflict, but they also show extensive healing. Individuals survived injuries that would have been fatal without immediate medical attention and long-term care. Broken ribs had healed properly, suggesting immobilization and rest. Infected wounds had been cleaned and tended until recovery. This care required detailed medical knowledge. Treating serious injuries in Ice Age conditions demanded an understanding of wound cleaning, bone setting, and infection prevention. The successful healing patterns in Neanderthal remains suggest sophisticated medical practices passed down through generations. The emotional implications are equally significant. Caring for disabled individuals offers no immediate survival advantage to the group. It requires resource investment with no return. The only motivation is empathy, the recognition that group members have value beyond their productive capacity. The predation theory cannot account for this evidence. Specialized predators don't develop complex medical practices or invest resources in disabled group members. The care patterns revealed in Neanderthal remains demonstrate emotional bonds, social responsibilities, and moral systems that mirror our own. In 2010, the Neanderthal Genome Project delivered a revelation that made the predation theory biologically impossible. When researchers compared ancient Neanderthal DNA to modern human genomes, they found something extraordinary. Every non-African human population on Earth carries Neanderthal genetic material. The implications were immediate and absolute. Modern humans and Neanderthals had interbred successfully, producing fertile offspring whose descendants survive to the present day. Between 1 and 4% of the genome of every European, Asian, and Native American individual comes directly from Neanderthal ancestors. This genetic evidence demolishes the predation theory at its foundation. Successful interbreeding between species is biologically incompatible with predator-prey relationships. Animals do not produce viable, fertile offspring with the species they hunt for food. The presence of Neanderthal DNA in billions of modern humans proves beyond doubt that our relationship was occasionally reproductive, not predatory. The interbreeding wasn't a single event, but occurred multiple times across different populations and time periods. Genetic analysis reveals at least 3 distinct waves of human Neanderthal hybridization, suggesting sustained contact between populations over tens of thousands of years. This pattern contradicts the idea of Neanderthals as human predators and supports a model of occasional cooperation and intergroup mating. The functional significance of inherited Neanderthal genes reveals further evidence against predatory specialization. Many Neanderthal genetic variants that survived in modern populations are related to immune system function, skin and hair characteristics, and metabolism. These aren't the genes of specialized predators, but of populations adapted to specific environmental challenges. Some Neanderthal genetic variants appear to have provided survival advantages to early modern human populations. Genes related to cold adaptation and disease resistance from Neanderthal ancestry helped modern humans survive in northern environments. Rather than being hunted by Neanderthals, our ancestors were occasionally interbreeding with them and benefiting from their evolutionary adaptations. The geographic pattern of Neanderthal ancestry also contradicts the predation model. If Neanderthals were primarily human predators, we would expect to find evidence of this relationship in the form of selective pressure against hybridization. Instead, we find the opposite: successful integration of Neanderthal genetic material into expanding human populations. The genetic evidence extends beyond simple ancestry to reveal behavioral compatibility. Successful interbreeding requires not just biological compatibility, but behavioral coordination. Individuals from different species must be able to recognize each other as potential mates, coordinate reproduction, and integrate offspring into social groups. This level of behavioral similarity contradicts the idea of fundamentally different predatory and prey species. Recent advances in ancient DNA analysis have revealed even more complex relationships. Some modern human populations show evidence of multiple episodes of Neanderthal ancestry, suggesting ongoing contact and reproduction over thousands of years. The genetic record documents not predation, but the gradual blending of two human lineages sharing the European landscape. The DNA evidence provides the final incontrovertible proof. We didn't flee from Neanderthal predators. We occasionally mated with them, and their genetic legacy flows through our veins today. The nightmare theory of Neanderthal predation crumbles in the face of our own genomes. The Neanderthal Predation Theory painted them as monstrous predators that shaped our psychology through fear. But decades of archaeology tell a different story. Neanderthals were fellow humans, adapted to Ice Age climates, with technologies, social care, medical knowledge, and even art. We lived alongside them, sometimes competing and sometimes interbreeding. Perhaps the most significant revelation is how easily we were willing to accept the predation narrative. Careful evidence shows intelligence, compassion, and culture evolving independently in multiple human lineages. Human evolution was shaped not only by violence, but by adaptation, cooperation, and innovation. Neanderthals weren't always our enemies. They were also our cousins, and their legacy endures in our genes.